Hello everyone, this is my Alexander Master Toolmaker. It needs special curved T-nuts manufactured so the vertical head can be secured in place. We've worked out a design, we've found some material to make them from, and we've built a fixture plate to hold our job to the rotary table. All we need to do now is work out where to place our cutter and we can start to machine our curved T-nuts. This is part 3 of a set of 3 videos. If you haven't seen the previous 2 and would like to, links to them are shown in the description at the end of this video. Let's recap. This is the setup we performed on the machine in the last video. As can be seen, I've put the centre back in the centre of the rotary table. The centre is still present in the vertical head, and I've lined the 2 points up exactly. Now we're not going to be moving the table anymore in the y-axis, so down there on the left hand side of the table I've done the lock up so it physically can't move now in this direction. All of our movement is only going to be in X. We're going to be moving the table in that direction. Now to eliminate the backlash, what I'm going to do is first of all move the table this way and now move it back, and then keep going until that or those centres are exactly in line. And at that point, just there, I will adjust the scale on the X wheel to 0. So I undo the clamp, bring this round until the 0 is in line with the line, and tighten it up. So I now know that if I'm moving the X wheel clockwise and taking the bed in that direction, when it comes to the 0, I know that the vertical head is directly over the centre of the rotary table. I've placed a cutter in the chuck of the machine. And now some graphics. That cross on the left is representing the centre of the rotary table. These 2 lines represent the finished inside and outside edges of our job. The inside edge of the job needs to be on an arc 57.79mm from the centre of the rotary table. Now how we arrive at that dimension is shown in part 1 of this video set. Links to part 1 are shown in the description. There's too much material to remove from the job in one cut, so we need to take several smaller cuts and slowly work our way out to the correct dimension. But what is the correct dimension? Is it 57.79mm? Well, let's go back to the graphics and take a look. This is the present position of the cutter. It's right over the centre of the rotary table. Now, let's move the table of the milling machine in the x-axis 57.79mm. This is where the cutter will end up, and as you can see, it's gone too far. And it's gone too far by half the diameter of the cutter. Let's go back to the beginning. Here we are again with the cutter right over the centre of the rotary table. Now look here, half of the cutter is already past the centre of the rotary table. The answer, of course, is we need to move the table the required dimension less half the diameter of the milling cutter, as that's on its way already. Our milling cutter is 7/16 of an inch in diameter. That works out to be 11.13mm. Divide that by 2 and we get 5.565mm. So we need to move the table 57.79mm minus 5.565. That equals 52.225mm. So let's do that and see what happens. Well, what do you know? It's spot on. The forward edge of that cutter is exactly 57.79mm away from the centre of the rotary table. I take a note of that dimension, 52.225mm. We will need it a little later to finish the cut on the inner surface of our job. The next thing we need to do is to find out the height of the fixture plate. I've now moved the bed over so the cutting tool is on top of our fixture plate. And now what I'm going to do is increase the height of the table. This will be coming up, which is just there. I'll now set the scale on the Z-axis wheel to 0, so I know the height of the fixture plate. I'm going to drop the table now by 1mm, which is just there. Now, what that means is when we start to cut the job, it's going to cut through most of the metal, but it's going to leave a slither of 1mm right the way across the bottom. Now, I'm doing that mainly because if we do decide to cut up through the centre with the cutter, I don't want these nuts becoming independent and possibly spinning around. So by having that 1mm of metal at the bottom, that will hold it all together. And then once they are machined, we can simply cut that 1mm off and then file it flat. That also means that we won't be cutting the fixture plate as well, which is good in case we want to use it for something else in the future. I've now applied the clamp on the Z axis, so that means that the milling machine is now clamped in Y and Z. So the only way we're going to be moving is left and right in X. The table itself will be rotating, so that will be going clockwise or anti-clockwise depending which side we're going to be machining. So the next thing to do is remove the centre. The cutter will be turning in a clockwise direction. When we come to cut the job, we want to cut the job from this end and feed the cutter in this direction. And that means the cutter load will go in this direction, and that will be against the thread of the rotary table, which is trying to turn it anti-clockwise. Now, if we went the other way and tried to cut from this end, the thread that's rotating the table, as the cutter touches this, the slack or the backlash in the thread will be taken up and the table will jolt forward. Then I'll turn it a little bit more, the cutter will dig in again and it'll jolt forward, and that's not good for the rotary table. It'll give a bad finish on here as well. So we need to cut from this end. This is called conventional milling. And if I cut from the other end, that's called climb milling. And in this particular instance, climb milling's not good, conventional milling is good. You will remember that on this face I scratched some guidelines that shows the position of the different cuts that we have to do. Well, this is the time where those guidelines start coming in useful. Now, we've got a big chunk to take off here. We can't take it off in one lump, so what I'm going to do is move the table over until we start to cut. Remember, we're going to be cutting from this end in this direction, and I'll take small cuts and then slowly bring this wall back. When we get close to that line, then what I'll do is take the cutter back to its datum position, and then I will slowly move the table over, measuring with the X wheel how far we've gone until the cutter just touches the metal. At that point I can then read off how far we've moved, which will then give me how much we've got to move to finish the cut. So with no further ado, let's get cutting. Now I'm going to cut full depth to start with. If we get too much chatter, then what I may have to do is go to half depth, but we'll see how we get on. So on with the motor. Just slowly moving the table over until we start to cut, which is just there, and I've got to move the table anti-clockwise. So now back to here, progress the table a little, let's put on, that's 0.3 of a millimetre, let's see how that goes. Let's come back to the beginning again. I'm pleased with the surface finish of the cut, that's looking pretty good. You can also see the beginnings of the 1mm thick spare material at the bottom. We are getting close now to our final size. I've brought the cutter back to its datum position, so the centre of the cutter is bang over the centre of the rotary table, and the scale on the X wheel is at 0. So what I'm going to do is move the the job towards the cutter, looking at the X wheel and counting off the distance that we travel. So that's 5, 10, 40, 45, and we're coming up to 50. So we'll start the motor now, and that will make a noise as soon as we touch that edge. That's 44 and a half. We're coming up to 50 there, 50.1, 4, so 50.4. 50.4, we've got to take that away from 52.3, so we've got just over a millimetre left to take off. The scale on the X wheel tells me I've got 0.6 of a millimetre left. Okay, the next cut will be the last one on this surface, so I'm just going to clean it up a little, get rid of all of the swarf that I can, so that it won't get trapped and cause a bad surface finish. Okay, then with coolant, I'll go up to the 52.1, 52.2 is just there. And take this last cut nice and slow. And there is our first finished surface. The surface finish is not bad, I'm quite pleased with that, and we've got our 1mm of spare material at the bottom. Right, the next surface to cut is the outside surface. So let's get set up for that. Now the cutter of the milling machine goes clockwise looking from the top. We want to conventional mill, so what that means is we need to start on this corner and then mill in this direction, and that way we'll get a better finish and it'll be kinder to the machines as well. I've moved the camera now so you can see the outside edge a little bit better. You remember this is the edge that I axawed across, so it's actually a V shape. What that means is there's 3 high spots, which one at each end and one in the centre. So as I'm coming across taking the cuts, and I've done it a couple of times now, it's cutting at each end and in the centre. And it's going to do that for a while until we get close to the actual size. So let's go across now and I'll take another cut and you can see what I mean. Right, we're back to our start position. I have turned the wheel 0.3 of a millimetre, which was the depth of cut we did on the inside, and that seemed to be pretty good because we wasn't getting much chatter. So I'm now going to start this cut. 1, and we're hit again in the centre, which is just, where is it? There it is. And then we keep going, and the last place we hit is the other end, which is just slow down here. That's the end of that cut. Now I come back quickly to the beginning again. Just like that. Move the table 0.3 millimeters in that, I'm sorry, in this direction, because we're cutting the outside diameter now. That's 0.3 of a millimeter, and we go again. I've just gone all the way around this outside face with no breaks, so it's actually cutting from one side to the other, which is good. I'm now going to just clean this up, and then we can have a look at that surface. I just want to do a sanity check on our dimensions. Now I've set the calipers to 57.79 millimeters, and that should be the distance between the centre of the centre that I've put in the middle of the rotary table and our inner face there. And when I line them up and put them like that, I've looked in from above and it's spot on. So we know that this radius here is correct. Now the diameter to here is going to be another 20 millimeters on, because the thickness of this T-nut is 20 millimeters. So I'm not going to bother to measure from the center out. I'm going to use this face as our datum face and keep machining this face here until the thickness of the T-nut becomes 20 millimeters, and that's our target dimension. So the thickness at the moment of our T-nut, our job, is, let's pull this together like that, pull it off, and 20.78. We must be getting fairly close now, so I'm just going to put the calipers across the centre, and we've got 20.04, and I'm happy that that is finished. Before we cut the two edges of our job, we need to get the cutter to the correct height. Now the correct height is 7 millimeters up from the surface of the fixture plate. Now the way that I found that height is I dropped the table down and then brought the cutter over this corner. And now you can see a piece that's been cut out. I started cutting a little bit higher, and then I used the depth gauge here to measure the height between the bottom of the cut and the table. Take one from the other and you end up with the part that's left here. And I kept going down until we got to exactly 7 millimeters, and that's where we are now, and we're ready to make our first cut. The cutter will be going clockwise in direction, looking down from the top. We want a conventional mill, so we're going to start our cut at this end of the job and then move in this direction. I'm going to start the motor, and then I'm going to advance the table in this direction just until the cutter touches the job, and as soon as we hear that, I'm going to take the cutter round to the beginning of our cut. I will then move the table 0.3 millimeters in this direction, which is the depth of cut we've been using for the other cut, so we know that that is good, and then we'll start this first cut. And it's just started touching there. So we're just touching the job. I'm going to move this around so we're up at the beginning of our cut. I'm going to zero the wheel on the X so I can use that for now progressing the table. So I'm going to go forward 0.3 of a millimeter, and now let's start our first cut. That's the end of the cut. We'll take the cutter back to the beginning and then advance the table on another 0.3 of a millimeter and then start our second cut. Our target width across here, it was 20 millimeters. We're now cutting this forward face, and we need to come back to 15.5 millimeters just across there, and at 15.5 millimeters we will be at the correct depth. At the moment we have 18.2, so we've got just under 3 millimeters to go. Let's do a little bit more cutting. Now, I'm pretty sure that was the last cut. Now I'm going to measure across the two flats here. Our target is 15.5, which is there. I've got 15.58 and our target was 15.5. So that is good enough. The inner radius is now cut to size, and we're about to start on the outside radius. Motor's running, and now I'm just moving it in X towards us until the cutter touches the surface of the job and that's just there. I'm going to zero the scale, so I'm going to rotate the table around to here so the milling cutter's off the job. Start the motor. Bring the table 0.3 of a millimetre in this direction. Remember that the cutter rotates clockwise, looking from above. We're conventional milling, so that's why we're starting at this end of the job. Advance in X in this direction, 0.3 of a millimetre. Our target width for this top part of the T-nut is 11 millimetres. So we've got 11.04. Well, that's not too bad, is it? We have one last face to machine, and that's the top face of the T-nuts to get it down to the correct height. At the moment, the depth gauge is telling me that it's 0.597 of an inch. Multiply that by 25.4 gives you 15.163 millimetres. It's got to be 12 millimetres high, so I've got about 3 millimetres to whip off the top of this, and that's the next thing to do. We're going to start this cut by taking the ends off of the two bolts, and then once we get that down to the top of the job here, we then cut right across that surface. I've just changed the cutter to a wider one. The original one couldn't get across this land in one hit, so I'd had to take 2 cuts every time I wanted to reduce this. So putting the large cutter in means that we can just do one pass, and that will cut the whole of the surface. So let's start the motor up and start cutting. Right, let's have a little measure. See how much we've got left to take off. Right, we just come down, and that's just touching the surface there. And we've got 0.556. 0.556. Now, what's that in metric? I've just been pressing the keys on the old plastic brain, and it tells me in millimetres it's 14.1. So it's 14.1 millimetres high at the moment, so we've got a couple more mil to take off. I've had a bit of a clean up, and I've just checked the height of the T-nut, and the depth gauge told me it was 0.472 inches, and that works out at 11.98 millimetres. So we wanted this at 12. We're doing all right. Now then, what's next? The shape of the T-nut should now be correct to fit into the slot. They are obviously a little bit long. I was thinking about milling the ends off to get them square, but I'm not going to do that now. I think it's time to remove the job from the fixture plate, deburr it, get rid of our 1 millimetre spare at the bottom, and then see if it fits in the slot. And now it's time to remove the job from the fixture plate. Right, it's now time to deburr all the edges and also cut off the 1 millimetre spare metal that I'd left at the bottom. I've just deburred our two T-nuts, which are sitting here and here, still joined together at the moment. The M12 bolts I've screwed into the tapped holes. I'm going to be shortening these by just underneath the height of the thread here, and this is the thread that you'll see sticking through the head of the Alexandra. Next job to do is cut the two T-nuts apart from each other down through the centre, and then have a look at the T-slot and work out what shape the T-nut's got to be so I can get in through that access hole and then into the T-slot itself. So that's the next job. And we have finished off the T-nuts. Hooray! Now, here's one of the T-nuts, and you see that I've Loctited in the piece of M12 studding, or it's not really studding, it was the end of that bolt. So that has now become our new T-bolt. And because it's shaped to suit the T-slot, I just put it in, you push it in through the access hole, drop it down, which is engaged into the T-slot, and now you can see it fits the T-slot quite nice. If I put the other one in, that fits in as well. There's no lubrication in there at the moment. I'll be greasing this up before I put the head back on. And because they have been made to suit the T-slot, they're going to be far stronger and they will spread the load a lot better than the old T-bolt once did. It is now time to remount the vertical head. So we'll put our piece of wood there, we'll grab hold of the vertical head and see if we can get the T-nuts in the back of the head through their holes. Now it's all been covered in grease, both the rear of the head and the casting behind it, so this should go on fairly easily. In fact, there we are, that's in place. Now let's put the nuts on. And look at that! The vertical head of my Alexander Master Toolmaker milling machine now has its full complement of T-bolts. Just here, I can move the head to the angle that I wish it at. I can then do up the two T-bolts which will secure the head in position. This job has been a success. And with that, this video is at an end. Take care everybody, and I'll see you next time. Could you do something like this? Of course you can.